So correlation is the next topic that we will be studying in business statistics under economics. Now, in this particular chapter, the basic rules, regulations, and laws, or the concepts that we have studied in our earlier chapters, some of them will be used here also. Things that we have learned in mean, median, mode, basically the chapter of central tendency, that those some of the same logic will now be used here as well. Okay.
Okay.
Specifically the part uh, where we did the assume mean, right? And the
Right.
deviation from assume mean. Those kind of the t value. So then those similar concepts will be used here also. But in general, the word correlation simply means mathematically the mathematical or the uh, relationship that exists between two variables or two data sets that can be expressed or calculated mathematically is known as correlation. Fine. So if we are trying to find the relationship, the mathematical relationship that exists between two variables or two data sets, that is known as
Hello.
correlation. Is it fine? So that's pretty much the basic idea of what correlation means. So that is pretty much thing. Now, moving on to further calculation, there are two types of correlation that can exist. The first is known as positive correlation, and the second one is known as negative correlation. Now, the logic between these two is very simple. Positive correlation means that if the value of variable x increases, the values of variable y
Okay.
will also increase, meaning that both will move in the same direction. Same direction. Okay.
Okay.
This is
Okay.
known as a positive correlation. On the
Okay.
other hand, what is the meaning of negative correlation? Negative correlation means that if the values of the variable x increases, the values of the variable y would decrease, meaning that there is a opposite, the movement is opposite. That is known
Okay.
as a negative correlation. Fine. So these
Fine.
are the basic ideas of what positive and negative correlation means. Positive correlation means that the movement in both the variables will be in the same direction, whereas negative correlation means that the movement in both the variables will be in opposite direction. Fine. And the
Fine.
examples are also clearly given. Now, going on to the next a category, linear and non-linear correlation. Now, linear correlation simply means that the movement or the change in the variable will be in such a way that if we plot them on a graph, it will create a straight line. Okay.
Okay. Okay.
So that is known as a linear correlation, that the movement or the change is such that it will create a straight line. On the other hand, non-linear correlation means that the change will be like the effect of change of one variable on the other variable will be such that it will cause anything other than a straight line. It will cause anything other than a straight line. So that is known as a non linear correlation. Fine.
Fine.
Is it okay? Now, simple
Okay.
correlation, multiple correlation is also one of the various categories of correlation. Simple correlation means that the relationship will be direct. Okay.
Okay.
And there will be there will be no complexity in the relationship, whereas multiple correlation would mean that there will be various complexities within that same two variables or two data sets. Okay. So that's
Okay.
pretty much the idea of simple and multiple correlation. Now the degree of correlation, what does the degree mean? Now degree of anything means the level or the percentage of something. Okay. Like if
Okay.
we say that what is the degree of the climate outside, so that is measuring the temperature, right?
Okay.
So then
Right.
here also degree of correlation simply means that how much is the effect, of change in x on the variable y. So that is like that is what we understand as the degree of correlation. That how much change in x is leading to how much change in y. Okay,
Okay.
understand this as a concept which is similar to elasticity. In economics, we have studied the concept of elasticity of demand and supply, right? So
Right.
then this concept is pretty similar to that elasticity relationship. Clear? Okay.
Yeah. Okay.
Moving on to the next one. This is pretty straightforward. If you just memorize this part, this table in in page 410 in your book also you will have this same table. Then that will be pretty much the end of it. No need to go too much in depth in this. Okay. Now, there
Okay.
are various ways now. This is the main part of the chapter where we will be trying to calculate correlation mathematically. Now, in order to do that, we have three main or most popular ways. The first one is known as a scatter diagram. This is obviously a
Okay.
graphical method because obviously in the name also you can see that the word diagram has been given. So this is a graphical method, whereas the other two are like calculative ways. The Karl Pearson's coefficient of correlation and the Spearman's rank correlation. Fine. So these are
Right.
basically the three methods that we have to study. Now the scatter diagram is very simple. In the scatter diagram, what we do is we simply present all the data sets onto a graph, and depending on how the graph looks, we try to estimate our correlation. So then these are the various types of correlation that we will have. That if all of the points are on the same straight line, then it will be a perfectly positive correlation. If all of the points are on like the one straight line but downward sloping, this is our upward sloping, this is downward sloping, this will be a perfectly negative correlation. Now, if we have a straight line and the points are around that, not on the same straight line, but somewhere around that, then it will be a positive correlation, not a perfectly positive. The positive and perfectly positive are similar, but not the same thing. In a perfect correlation, all of the points are exactly on that straight line. But in a positive correlation, the points are somewhere around that straight line. See, all of these red points, they are around that straight line, isn't it? So that's pretty much the different the idea. Okay.
Sir.
Yeah, tell me.
Yes, sir. I'm. Sir, in this, I'm unable to say that lines, sir, here in the
Which
whiteboard.
which lines? Which
Sir, you just now you explained this part, that part, no, sir,
okay, okay.
with the topic.
Yeah. Okay,
Yeah.
okay. Are you able to see them now?
Yes, sir.
Yeah.
Yes, yes.
Fine.
Yes, I'm able to see.
Okay. So you
Fine.
should have said this a while back.
Okay.
No worries. I think I was
Uh,
on presenting the whiteboard, but I was teaching from. Okay,
speak.
no worries. So is it clear?
Okay.
This
Okay.
part is clear.
Yes,
So
sir. Clear.
when all the points are on the same straight line, it is a perfectly positive. But if it is around or near the straight line, then it is a positive. Okay, fine.
Okay.
On
Fine.
the other hand, perfectly negative means that all the points are on the straight line but in the downward direction, whereas negative is that it is around the same straight line, moving downward but not on the straight line. It is around the straight line. Okay, so that's a
Okay.
negative one.
Okay.
Okay, and if
Okay.
there is a diagram like this, which is spread all around the data set, then there is no correlation at all. Is it okay?
Okay. Okay,
Fine.
sir. Fine.
So you need to memorize this very thoroughly. This is very important. Okay, so note down
Okay.
page 411, the scatter diagram. Cool. Now the next two, this was the diagrammatic method. Okay. Now the
Okay.
next one is Karl Pearson's coefficient of correlation. Now let's go into Karl Pearson's coefficient of correlation. The Karl Pearson's coefficient of correlation is, first of all, the formula is this. This is the formula. Okay, now the formula is very simple. I'll explain the formula in a minute. First of all, do one thing, note down the formula.
Okay.
R is equal to summation xy whole divided by, just one second.
Yes, sir. Done.
Noted.
Yeah.
Now, don't be worried about the formula. The formula application is very simple. Okay,
Okay.
let's take a look
Okay.
at a question directly. See, this is the question. Actually, this is the formula you should note down. Cut that earlier formula. Note down this formula. This is the formula that you need to note. Cut that
Uh,
earlier formula. This is the formula that you need to. This is why I stopped, because I was confused about that formula. This is the formula that you should be actually note. Okay,
okay.
fine.
Fine.
Now we will solve this question using that formula. So you have two columns, X and Y, meaning that you have two data sets, X and Y. Okay.
Okay.
Now write, so in based on this question, you will write the X data set first like this. Okay.
Okay.
2, 3, 4, 5, 6, 7, 8. Okay.
Okay.
And then you will calculate the average of that. Calculate the average. How will you calculate the average of this data set?
Uh, sir, by by using the formula R is equal to summation xy by.
No, 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 no. Average. Average. How will you calculate average? How will you calculate, forget average. How will you calculate mean?
Yeah, summation uh, uh, FM by F.
Revision is needed, Raghav. Okay.
Okay.
I I will not always be able to tell you that you have to revise this and this and this. You have to revise by yourself also. The
Um,
formula is summation x by n, because this is an individual series. The formula that you were trying to remember, that formula is summation fx by summation f. That is for a discrete series, but this is a individual series. Here the data is single individual data. So then the
okay.
formula here will be summation x by n. Okay,
Okay. Okay.
meaning that you will add up all of these values and divide it by the number of values, normal average. How do you find the average of some values? These are some values, you just have to find the average of that. Okay,
Okay.
fine. So then do that, add up all the values. How much is the total of all the values if you add them?
Uh, uh, 35, sir.
And how many values are there?
7.
So then the average is 5.
5.
Okay. Now what we will do is we will calculate small x. Okay, this was capital X. Now you will calculate small x. Okay. Now
Okay.
how will you calculate small x is by subtracting this value from each of these values. Fine.
Okay.
Is it
Mm,
okay? So then what you will do is you will do 2 minus 5, 3 minus 5, 4 minus 5, 5 minus 5, 6 minus 5, 7 minus 5, 8 minus 5.
Minus 3, minus 2, minus 1, 0, 1, 2, 3.
Okay, do it in your note. And then you will calculate the square of this also. 9, 4. Is it okay? To here?
Sir.
Is it okay up to here?
Yes, sir.
So did you calculate the x column?
Uh,
This column. Did you do this?
oh, small x. Okay. Yes,
Yeah.
sir. Did.
X
Did.
square.
X square have to do.
Do it quickly. And then you will do the same thing for the y value, where you will write all the capital Y values here. 4, 7, 8, 9, 10, 14, and 18. Then you will find the average, and then you will find the small y, and then
Okay.
you will do the y square. Calculate all of the values. Calculate all of the values for y
Y
also.
by.
Yeah, yeah. First do the x square, then you do the y,
Done, sir.
and do the y value now.
Yeah.
Do capital Y, then small y. First find the average of this, then
Okay.
subtract each 4 minus that average value, y bar value.
Okay.
7 minus y bar, 8 minus y bar. Do it. Okay. So then you have calculated the values of x, then you have calculated the average, then you have done the small x, then you have done the square of that. Okay. And
Yeah.
we got these three columns. Okay. For x, we got this, this, and this. This is your small x. This is your x square.
Okay.
Similarly, for y also you calculated the average. How much did you get the average? Y average was how much?
10, sir.
So they have also got 10. Then you did the y, small y. Yes. Did you get
Yes.
these values?
Yes, sir.
Very nice. And then you did y square,
Yes, sir.
isn't it? So
Yes.
then you got all of these values. Okay.
Yes.
Now focus carefully. You will multiply the small x and the small y to get the x y column. Do it. Now your task is to multiply your small x and small y in order to get the small x y column.
Okay.
Basically these two columns.
Sir.
Once you are done with the small xy column, what you will do is you will see the formula. In the
Okay.
formula, you will see that exactly these things are required. The first is the total of this xy, small xy column. The
Okay.
second is the total of the x square column and the y square column. Okay.
Okay. Okay.
And that is it. So then you will put all the three things in the formula, and that is your correlation. This R is your correlation. Fine.
Okay.
Complete
Fine.
the small xy column and do all the three things. So just now you have calculated the total of the three columns, right? The
Uh,
first you calculated the total of the small xy column, isn't it?
yeah.
This column you calculated. You got 58, I hope.
Yes, sir.
Then earlier you had calculated the x square column and the y square column. Right now
Yeah.
you just calculated the total.
Yeah.
Yes. Now in the formula you need these three values only. The total of x square column, the total of the y square column, and the total of small xy column. Put
Okay.
all the three things in the formula.
Okay.
This is your correlation formula which you wrote a little while back, right? So
Yes, sir.
then you will do R is equal to 58 divided by under root 28 into 130. Calculate this. This is your correlation. This is your Karl Pearson's correlation of coefficient of correlation. That's your
Uh,
answer. Okay, are you clear?
yes, sir.
Do it quickly.
Okay.
So basically, now that you have calculated, you would get 0.96 as your final answer, which means that the correlation between the x and the y values, capital X, capital Y value, meaning the values given in this data set, is 0.96, indicating that if the value of x changes by 1 unit, then the value of y will change by 0.96 units. And that is basically what the correlation means. Okay. Is it
Okay.
fine? So
Fine,
that
sir.
is pretty much the idea. So what just orally give me an explanation of the calculation process that we just did. Can you do that?
Yes, sir.
Tell me. First, what will we do?
Yes, sir. First, we will calculate the average, sir. Mean. First, we will calculate the average
Of each of the
each each of
yes,
the value.
each of the data sets. So first we
Yeah.
will calculate the mean of x and also the mean of y. Okay.
Mean of it. Yes, sir.
Then
Then after calculating, we will after calculating the average value of x and y data set, we will find the small x and small y values, sir.
mhm, how will we do that?
Sir, we will subtract, we will m-
Subtract all the x values from the mean of x and
subtract x from all the mean of x. And similarly, the values of y to
Mean of
y, mean of
mean of
y.
perfect. Okay. And then we will do calculate the x square, y square values.
Yes, sir. We will calculate
Small,
x square, y square values.
small x, small x.
Uh,
Do remember small x square, small y square. And then we will make one more column, which is the x into y column, small x into small y column. And
yes, sir.
once we have done all of that, we will calculate the total of the x small x square value, calculate the total of the small y square value, and calculate the total of the x small x into small y value, and put all of that in the formula. And
All
that
in
will
this
give us
formula, and we will calculate it further.
the this. What is this that we are calculating?
R, small r,
Carl, Carl Pearson's coefficient of correlation.
coefficient of r,
Correlation. Okay. This R is known as
coefficient
the Karl Pearson's coefficient of correlation.
of
Okay, note it
correlation.
down. Note it down. This small r and this entire formula is for calculating Karl Pearson's coefficient of correlation.
1 second, sir. Right.
Yeah, it's given. It's given here also. It's given here also because the topic heading itself is Karl Pearson's coefficient of correlation. Okay, fine.
Oh, fine.
Okay. So that's it. That's this topic. The first method we have learned.